In the present discussion, we have to talk about the propagation of an electromagnetic wave in free space. For that, we should consider the Maxwell's field equations. Dive D equal to rho, which is our Gauss law in electrostatics. Then dive B equal to 0. This is Gauss law in magnetostatics. Curl E, which is equal to minus dou B by dou T, Ampere's Faraday's law. Then curl H equal to J plus dou D by dou T. This is our Ampere's circular law. If you consider the D, displacement vector is equal to epsilon into E. This is our permittivity. E is our electric field. Then B equal to mu into H. Mu is our magnetic permeability. Then current density J equal to sigma into E. Sigma is our conductivity. Then the displacement vector D equal to epsilon into E. Epsilon is our permittivity. Now we have to modify these equations for a free space. For a free space, rho equal to 0. Charge density is 0. Then current density J is also 0 because the conductivity sigma is 0. Then J equal to 0. Sigma is our conductivity. Then mu is equal to mu naught and epsilon is equal to epsilon naught. To understand more about these two things, think about our relative permeability. Relative permeability, mu suffix r is equal to permeability of the medium divided by permeability due to free space. Permeability of the medium is mu. Permeability of the free space is mu naught. Therefore, mu is equal to mu naught into mu r. Suppose the medium itself free space. Mu is also replaced by mu naught. Mu naught by mu naught is 1. Therefore, mu r is equal to 1. In the case of free space, mu r equal to medium. Medium is free space, mu naught, divided by this permeability due to free space. So the value of mu r is equal to 1. In this formula, if you put mu r is equal to 1, mu equal to mu naught. For a free space, the value of mu equal to mu naught. In the same manner, permittivity, relative permittivity equal to permittivity of the medium divided by permittivity of free space. Suppose the medium is free space. Here we have to put epsilon is replaced by epsilon naught. Epsilon naught by epsilon naught is 1. So epsilon r is equal to 1. Therefore epsilon equal to epsilon naught. So these are all the things we have to substitute for a free space in the above equation. Rho equal to 0. Rho equal to 0. Then sigma equal to 0. Then automatically J equal to 0. Mu is replaced by mu naught and epsilon is replaced by epsilon naught. Now we have to write the Maxwell's field equations for a free space. Consider the first equation, div D equal to rho. For a free space, this is a Gauss law in electrostatics. You know that D equal to epsilon into E. Displacement vector D equal to epsilon into E. But the value of rho is 0 for a free space. So del dot epsilon E equal to 0. Therefore, del dot E equal to 0. This is the first Maxwell's field equation for free space. Here actually D equal to epsilon into E. That means del dot epsilon E which is equal to 0. For a free space, rho equal to 0. Del dot E, which is equal to 0 by epsilon, that is equal to 0. So this is our first Maxwell's field equation for a free space. Now come to our second equation. You know that B equal to mu H. B equal to mu H. For a free space, mu equal to mu naught. So del dot mu naught into H equal to 0. So del dot H equal to 0 by mu naught, that is equal to 0. So del dot H equal to 0. This is the second equation, Maxwell's field equation. This is Gauss law in magnetostatics. This is Gauss law in electrostatics. Now come to our third equation. Curl E equal to minus dou B by dou T. Curl E is equal to minus dou by dou T of B equal to mu H. For a free space, mu equal to mu naught. So B equal to mu naught into H. So minus mu naught dou H by dou T. This is equation 3. This is third Maxwell's field equation. This is nothing but our Faraday's law. Come to our fourth equation, curl H. Del cross H, which is equal to the value of J equal to 0 for a free space, because J equal to sigma E, conductivity sigma equal to 0, automatically J equal to current density J equal to 0. Then D equal to epsilon E. You know that D equal to epsilon into E. For free space, epsilon is epsilon naught. So D is replaced by epsilon naught into E. So curl H equal to epsilon naught dou E by dou T. This is our fourth Maxwell's field equations. For a free space, the Maxwell's field equations are modified in the above manner. Now take the curl of equation 3. Curl of equation 3 gives, see, this is equation 3, del cross E, which is equal to minus mu naught dou by dou T of curl H. Say this is equation 5. Just we have taken the curl of equation 3. Now we have to expand the left hand side using the formula. Del cross E equal to gradient of div E minus del square E. This is the formula, which is equal to minus mu naught dou by dou T of the value of curl H is epsilon naught dou E by dou T. Epsilon naught dou E by dou T. We know that div equal to 0 from the equation 1. Div equal to 0. So the left hand side is minus del square E, which is equal to minus mu naught epsilon naught dou by dou T of dou E by dou T is dou square E by dou T square. Del square E, which is equal to mu naught epsilon naught dou square E by dou T square. Then del square E minus mu naught epsilon naught dou square E by dou T square, which is equal to 0. Say this is equation 6. Now take the curl of equation 4. del cross H, which is equal to epsilon naught dou by dou t of del cross C. Expand this left hand side using the identity grade of del H minus del square H, which is equal to epsilon naught dou by dou t of the value of curl is minus mu naught into dou H by dou t. From equation 2, del dot H equal to 0. The above equation is modified as del square H, which is equal to minus mu naught epsilon naught dou square H by dou t square. So del square H equal to mu naught epsilon naught dou square H divided by dou t square. Del square H minus mu naught epsilon naught dou square H by dou t square is equal to 0. Say this is equation number 7. Now 6 and 7 are compared to the wave equation del square psi minus 1 by v dou square psi by dou t square is equal to 0. See that the equations 6 and 7 are compared to the wave equations del square psi minus 1 by v square into dou square psi by dou t square is equal to 0. This is our general form of the wave equation. So this is equation 8. From the equations 6, 7 and 8, we may write the value of 1 by v square is mu naught epsilon naught. If you compare the equations 6, 7 and 8, we may write the value of v square is 1 divided by mu naught into epsilon naught. The equations 6 and 7 are identical with the general wave equation del square psi minus 1 by v square into dou square psi by dou t square is equal to 0. Therefore, 1 by v square is equal to mu naught into epsilon naught. See, to compare equation 6 with our 8, del square into psi. Del square is an operator, psi is a function, here v is a function. Then minus 1 by v square into dou square psi by dou t square. Here dou square by dou t square into v. So instead of 1 by v square, we can write mu naught into epsilon naught. Therefore, v square is equal to 1 by mu naught epsilon naught. Then v equal to 1 divided by mu naught into epsilon naught inside the root. This is the velocity of an electromagnetic wave in a free space. Now I have to find out the value of v. We know the value of mu naught. Mu naught is 4 pi into 10 power minus 7. The value of epsilon naught is 8.85 into 10 power minus 12. If you substitute these values in the equation, 4 pi into 10 power minus 7 into 8.85 into 10 power minus 12 inside the root, you can get the value of 3 into 10 power 8 meter per second. Say this is equal to the velocity of light. Suppose an electromagnetic wave is passing through free space, its velocity is equivalent to velocity of light.